Hello, welcome to Astronautics for Exploit. This is Dr. Ayanshola Ogundele. Orbital City, a space city for human civilization growth and evolution into outer space. The focus points of my presentation are as follows. Orbital City, advantages of Orbital City requirements, and Orbital City locations. Orbital City, also known as Space City, and firstly conceived in the 19th century, is a proposed self-contained and an advanced form of living quarters in space for the permanent settlement of humans. Based on research studies that show that rotation is a healthy substitute for gravity, the Orbital City concept design is to rotate in orbit to prevent long-term exposure of its residents to the dangers of weightlessness or microgravity. Presently, Orbital City, a planned futuristic city for the evolution and expansion of humanity to outer space, is receiving renewed interest from the space enthusiasts, government, private space companies, and space investors. Several companies are planning the development and launching of orbital cities. An example is Think Orbital Company, which is developing a cost-effective, pressurizable, scalable, and multipurpose infrastructure called Think Platform Space Station. The station can be used for on-orbit servicing, assembling and manufacturing, space tourism and research. The company's football-like Think platform is a spherical space station being developed to unlock potentials of orbital cities and shipyards. Also, Blue Origin is developing Blue Origin space-based orbital habitat, an orbiting space station where people could live and work. The vision was based on space settlement designs that were firstly conceived by the physicist Gerard O'Neill. Orbital City. Orbital settlement is an advanced form of living quarters that is space station or habitation model which is intended as a permanent settlement in outer space. Although presently there are no space habitat constructed yet, but various orbital city design concepts have been proposed by engineers and science fiction authors. Illustration of mass sample return program is shown in this picture. An orbital city can be built in orbit around a chosen candidate such as the Moon, Mars, or an asteroid. An orbital settlement is being proposed as a self-contained structure envisaged for microgravity environments where there is complete or near complete absence of the sensation of weight, referred to as weightlessness or 0G. Both illustration of astronauts inside International Space Station is shown in this picture. Long-term exposure prevention. A space habitat known as Orbital City is a large-scale habitation facility in outer space or in an orbit. It is also known as space settlement and is usually designed to rotate so as to prevent long-term exposure. Research findings shows that rotation is a healthy substitute for gravity. A floating city in orbit around the rocky moon is shown in this picture. Motivations for orbital city are survival of human civilization and the biosphere in case of a disaster on the Earth, huge resources in space for expansion of human society, expansion without any ecosystem to destroy or indigenous people to displace, to help the Earth by relieving population pressure and taking industry off Earth. An illustration of interior of Stanford Torus Orbital City is shown in this picture. Advantages of orbital city. There are various advantages of orbital cities such as accessibility to solar energy, in-situ resource utilization, easy material extraction, gravity well, population capacity, zero-G recreation, and easy traveling to the other planets. Space has an abundance of light produced from the sun. In Earth orbit, this amounts to about 1,400 watts of power per square meter. Solar energy can be used to produce electricity from solar cells or each engine-based power stations, process oils, provide light for plants to grow and to warm space habitats. Football-like think platform, a spherical space station which could unlock orbital cities, is shown in this picture. Space habitats may be supplied with resources from extraterrestrial places like Mars, asteroids, or the Moon. Breathing oxygen, drinking water, and rocket fuel can be produced with the help of in-situ resource utilization, and it may become possible to manufacture solar panels from lunar materials. Illustration and orbital space settlement is shown in this picture. Another advantage of orbital city is easy material extraction. Most asteroids have a mixture of materials they could mine, and because these bodies do not have substantial gravity wells, it will require low density to draw materials from them and haul them to a construction site. It has been estimated that there is enough material in the main asteroid belt alone to build enough space habitats to equal the habitable surface area of 3,000 Earths. A prototype of orbital city is shown in this picture. Another advantage of orbital city is gravity well. Earth-to-space orbital trade will be easier than Earth-to-planetary orbital trade, as orbiters orbiting Earth will not have a gravity well to evacuate to export to Earth, and a smaller gravity well to evacuate to import from the Earth. Researchers assume that collection of all the material in the main asteroid belt will allow orbiters to be constructed to give an immense total population capacity. An artist's concept of a research station in the class of Venus is shown in this picture. Another advantage of orbital city is zero-G recreation. If a large area at the rotation axis is enclosed, various zero-G sports are possible, including swimming, hang gliding, and the use of human-powered aircraft. An orbital city of space habitats can be the passenger compartment of a large spacecraft for colonizing asteroids, moons, and planets. Artist rendering of a crude floating outpost on Venus is shown in this picture. Orbital city requirements. Orbital cities are expected to provide all the material needs for hundreds or thousands of humans in an environment out in space that is very hostile to human life. Atmosphere, food production, adaptive gravity, protection from radiation, heat rejection, and ability to withstand meteoroids and dust and altitude control are another expected requirements. Rendering of the inside of Orbital Station is shown in this picture. For the atmosphere, the requirements are as follows. Air pressure with normal partial pressures of oxygen of 21%, carbon dioxide and nitrogen 78%, and is a basic requirement of any space city. Organic materials for food production will also need to be provided. At first, most of these will have to be imported from the earth. One proposed recycling method will start by burning the cryogenic distillate, plants, garbage, and sewage with air in an electric arc and distilling the result. Orbital assembly space stations, which will have office space as well as accommodation, is shown in this picture. Long-term on-orbit studies have proven that zero gravity weakens bones and muscles and upsets calcium metabolism and immune system. Most people have a continuous stuffy nose or sinus problem. Artificial gravity substitute for gravity. Most orbital designs will rotate in order to use inertial forces to simulate gravity. NASA studies with chickens and plants have proven that this is an effective physiological substitute for gravity. Proposed Axiom Space Commercial Space Station is shown in this picture. Protection from radiation. If a space habitat is located at L4 or L5, then its orbit will take it outside of the protection of the Earth's magnetosphere for approximately 2/3 of the time. Orbital cities need a radiator to eliminate heat from absorbed sunlight. Proposed Northrop Grumman space station is shown in this picture. Orbital cities will need to withstand potential impact from space debris, meteors, dust, and a host of others. Most meteoroids that strike the Earth vaporize in the atmosphere without a thick protective atmosphere meteorites. Most mirror geometries require something on the orbit to be aimed at the Sun, and so altitude control is of high importance. Orbital Reef Commercial Space Station project is shown in this picture. Orbital City locations. Orbital City's orbits are still under the consideration, and so orbital station keeping is probably a commercial issue. The lunar L4 and L5 orbits are now thought to be too far away from the Moon and Earth. Proposed Pioneer Orbital Station is shown in this picture. Another proposal for the Orbital City location is to use a 2-to-1 resonance orbit that alternately has a close low-energy approach to the Moon and then to the Earth. The TETES system. Rational orbit provides quick, inexpensive access to both raw materials and the major markets. Most orbital designs plan to use electromagnetic theta propulsion or mass drivers instead of rocket motors. The advantage of this is that they either use no reaction mass at all or use cheap reaction mass. Proposed space hotel is shown in this picture. For more information, contact Astronautics for Exploit. You've been watching and listening to Orbital City, a space city for human civilization growth and evolution into outer space, presented by Dr. Ayoshola Ogundele, Astronautics for Exploit, with the focus points: Orbital City, advantages of Orbital City requirements, and Orbital City locations. Thank you.